A frameless pack feels lighter in your hand, but once you exceed 12 kilograms, the physics of load transfer collapse, effectively doubling the metabolic cost on your shoulders. Stop treating your pack as a storage bag and start viewing it as an exoskeleton. Whether you are on foot or wheels, you are solving a systems engineering problem, managing the moment of inertia against your body's chassis. The golden rule of human load carriage is the 80-20 split. To minimize muscular fatigue, the iliac crest, your hip bone, must support the static load, leaving the shoulders to manage only dynamic stabilization. This is where internal frames justify their weight. Rigid aluminum stays, or carbon sheets, act as a force bridge, transmitting vertical force directly to the lumbar pad. Without this stiffness, the load sags, creating a lever arm pulling backwards against your spine. Ultra-light frameless packs rely on virtual frame physics, using the sleeping pad and gear compression to create rigidity. However, this has a hard limit. Once the internal pressure fails to resist the load, the pack collapses. Load lifters are not just straps, they are vector adjusters. By applying tension at a 45-degree angle, you pull the pack's center of gravity forward, aligning it with your spinal axis and reducing the torque on your lumbar region. On foot, we want the center of gravity high and tight to match our walking mechanics. But when we switch to bikepacking, the physics invert completely. A high load on a bike acts as an inverted pendulum, destroying your handling. Seat packs are popular for aerodynamics, but they introduce the tail wag effect. If the pack isn't rigid, the cantilevered weight creates lateral momentum during out-of-saddle climbing, fighting your pedal strokes. The frame bag is the superior solution for heavy items like water and tools. By placing mass inside the frame triangle, you lower the bike's polar moment of inertia, making the bike feel lighter than it actually is during cornering. Panniers offer the lowest center of gravity, but suffer from a massive aerodynamic penalty. It's a trade-off, the mechanical stability of panniers versus the watt-saving profile of a bikepacking setup. Material science dictates the carry quality. High denier nylons provide the structural stiffness needed to transfer load. Lighter fabrics like DCF rely entirely on hoop tension. If the pack isn't full, the structure fails. Analyze your route profile. If you're climbing technical verticals, the internal frame's load transfer is safety equipment. If you are racing flats, the aero advantage of a frameless seat pack wins. Comfort isn't about padding. It's a math equation of weight distribution and rigidity. Stop buying gear based on hype and start building a system based on physics. Respect the physics, and the miles come easy.